Hello everyone, welcome to one more episode of CodandoTV. Before we start, please don't forget to leave your like and start subscribing our channel to stay tuned to all of our news about mobile development. Let's follow up. Today we're going to talk about a very important concept in mobile development in Flutter, which is state management. What is state management? State management is basically the way that we manipulate the logic, right, of some screen, and we bind that to the UI, which should stay static, dumb, and it's not supposed to know anything about our business and presentation rules. So we already talked about stateful widgets, which is the standard way Material provides us to link the business logic to our UI. The stateful widgets have a state class, right, that contains some properties that should be updated in order to trigger a UI update. This UI update that's triggered every time we change some property in our state is known as recomposition. This term is not hugely adopted in Flutter, more in KMP, but in Jetpack Compose, but let's call this way. So let's show what is our project. Our project is basically a sum calculator. How does that work? We usually type one number, 1, and then a second number, 1, and then we show a result here. We show the first number that's bound to the first number field, another one that's bound to the second number field, and then we add each one to the other, and that results in 2 or 3, 5, and everything. And how is that structured for now? We are currently relying on a stateful widget. The stateful widget is basically it contains a state class, right? And this state class is bound to our page, which is the stateful widget itself. The stateful widget is only supposed to be inserted in a widget tree, and the state itself contains the text editing controller 1 and 2. Each text field should have a controller which supposed to imperatively update the text. We have this function update sun, and every time we want to trigger a change in the state, we call this set state function. And something I don't like with this approach is that the UI tree itself, the widget, is declared inside the state. And that's weird to me because the state is supposed to only have business logic. It's not supposed to mix with UI. So don't confuse that with MVVM because it's definitely not MVVM. In the MVVM, the view model is not supposed to know anything about the view. It's only supposed to trigger UI updates with some presentation logic, and some UI that's subscribing to it is supposed to listen. It's a very straightforward example of the observer design pattern. And as the UI is inside the state itself, we definitely cannot call that an observer pattern. So it's not MVVM at all. What are we gonna do in order to divide the logic, the UI, from the presentation logic? We're gonna rely on a library called Cubit in Flutter. What is Cubit? Cubit is a library that implements a class called Cubit, right? And the Cubit, it's supposed to be attached to a generic type, which is the state, and the state corresponds to some data aggregations, a data structure that every time a new state is generated, or better saying emitted by our Cubit, the UI that is listening to it shall be updated. So in this case, we are definitely implementing the observer pattern. Let's migrate this project, this very simple page, to Cubit. And we're not relying on stateful widget anymore. Let's start by integrating, no, not Cubit. It's a library called Flutter block. It's already installed. So, okay, if you want to install that, just add your dependency with Flutter, but add Flutter block. Okay? Brilliant. So, what are we gonna do? We're gonna remove the state from here, and that will be changed to a stateless widget. We're gonna fix that very soon, but let's implement our Cubit first. Some calculator, I will call that view model. People in the community usually call the view models as Cubit, but as we are definitely implementing the view model, the MVVM pattern, I'm gonna call that view model. But definitely that extends from a Cubit. And I will create another class. State.dart. Some calculator state, and I'm gonna have three values actually. The first one, it's a string that I will call first number. Another string called second number. And the last one, that is the result. All the three of them will be strings. And we need to implement a constructor here. First number, second number, result. Let me add a comma here to break lines. Okay, now we have our data structure for the state. Okay, let me attach to the some calculator state. And we need to initialize our some calculator view model. I need to provide another thing here. An initial value, because the Cubit, which is our view model, should have an initial state to be started. So I will add that as a computed property, get, and initial value. I will add 0, 0, and 0. Okay. Now that we have our default value, let's initialize with the sum calculator state initial value. Perfect. Okay. Now let's implement two methods that are essential to update our Cubit that will be triggered during user interactions. And what we desire here, function to handle when this field is changed, and another one for the second number field. Let's add the first function, the change first number field. What are we gonna do now? Every time our state changes, we are supposed to trigger a UI update in our page. So what are we supposed to do? We are gonna rely on a function called emit. Emit is a function that emits a new state that will update our page. So our page class, that is the stateless widget that relies on Cubit, will trigger a new UI that will render once more every time we emit a new state. So remember, emit function changes the UI. Every place in the UI that listens to the view model, to the Cubit, shall be updated. So let's add a new. First, another thing that's very useful to us is to provide a function called copyWith. This function will return a new state every time we change one of the fields. So, first number, second number, result, and this is required. That's saying that this parameter is mandatory for this function. Required and required. Okay? Perfect. And here we are gonna return a new state. So actually, I will not. That's supposed to be nullable because we are not gonna provide all the fields at the same time. The advantage of that is being able to provide just the values that we're supposed to definitely change. So first number, this first number. This is an optional wrap. If the first number we're providing in this function is new, we're gonna provide the same value as before. Remember, this state is not able to be changed. We're only able to provide a new state every time we are gonna update our Cubit. So here we are gonna provide the second number. Result, this result, otherwise. Perfect. Okay, now we have our copyWith function. Because our state is immutable, let's call state copyWith. Oh, let's receive an integer value here. Number. And first number will be number.toString. We're gonna send a string, not an integer, to be presented. And result will be number plus state.second number as int. ToString. Actually, in order to everything to be even more easy, I set that as integers, because we're gonna just do the parse in the UI itself. Let me change that. 0, 0. That would be easier to not have too many typecasts. Int. Okay. Okay. And here, number. And we don't need this parentheses anymore. And okay. So this is our first function that will be updating the first number and the result. We are emitting a new state with the new first number and a new result that is resulted by a sum of number and the second number, the existing second number. Let's replicate that for the second field change. So let's change that to second number field. But instead of the first number, we are gonna change the second number. First number. Okay, so this is our view model extending from Cubit, which handles sum calculator state, and that's supposed to emit new state values every time we're manipulating the state data. This is a presentation logic layer. And every time a new state is emitted from this Cubit, the UI is supposed to change. But how is that supposed to work? Let's jump to our sum calculator, and instead of a state, we're gonna just have a stateless widget. Let me see. We're gonna replace that by a stateless widget, and we not have this state anymore. We are gonna rely on the build function here. How's that supposed to work? We are gonna return this entire scaffold here. We don't need the controllers anymore because we are not setting the text field values imperatively. So let's remove that. And we're gonna remove this entire state, okay? And here, instead of update sun, we're gonna pass, let's first declare our view model. There are multiple ways to sync our UI with the Cubit view model, but let's just illustrate with the easiest one, okay? Let's declare our view model. First things first, we usually inject the Cubit with the provider pattern. The provider design pattern is a way that we use to inject some piece of data or object inside our page hierarchy, which means in any level of our widget tree, we are able to retrieve that object, and that's what we're gonna do with Cubit. The first thing, let's create another widget here at the bottom called, let's declare it as private, sun calculator page content. That extends from a stateless widget. And let's pass our scaffold itself here. And instead of this UI, we're gonna pass a block provider. What is the block provider? Block provider is a widget that is used to inject a value to be retrieved in any level of the children. The value we are going to pass is the sun calculator view model. Okay? It's a sort of dependency injection, but it's not the same as get it. I'm going to have a video about get it soon. And we are going to pass a child, sun calculator page content. Oops. Okay. We are injecting this view model to our view hierarchy, and now here we are able to retrieve our view model through our build context object. You're gonna rely on a function called watch, okay? And let's declare the type we're expecting, sun calculator view model. The watch function is a way of retrieving the sun calculator view model object from the widget tree, and we are now watching for the changes in this Cubit. What does that mean? When we are watching that inside of widget tree, everything that's below this widget tree shall be updated every time a new state is emitted by this Cubit. Is emitted as, as in here. Okay, so we are already retrieving the view model, and instead of this function, we are gonna pass the change first number. Okay. It expects an integer, so view model did change first value, number as int. Okay, the same here below. Second value, second number field, sorry. And here, now is the time we rely on the Cubit. What does that mean? Here is a place where we need to show the value from our updated state. Instead of having this sum here, we're just gonna pass new model state result to string. Okay. I think everything's now working fine. Let's do a hot reload. Oops. What did happen here? Some calculator page stating on the subtype. Let's run the project again. Probably it was confusing with the state we were previously rendering. Let's run the project once more and see if the error persists. It's very important, okay, to have this block provider at the top and the other one, the page content, as a lower level, because we are injecting to the lower levels of the block provider. If we try to access the view model with the watch function here, the application will crash, as happened now. Okay, let's delete the application and try to run again. Let's see if we get this error again. I think that will work. I hope so. Okay, let's check. Now that we work. Perfect. Oh, I forgot. In fact, we need to show the other numbers of the sun. So let's create a new string here. We need to present the 3 numbers. Let's make a string interpolation here. First number. Oh, sorry. Plus the second number equals the third number. Okay, let's apply a hot reload and check if everything works as expected. It's complaining about some typecasts here. What is the problem? Type is not a subtype of int. Ah! That is the problem. Value as int, not none as int. I was passing the wrong value. This is none. Probably a Flutter predefined value. Value as int. Okay, sorry, let's try once more. Oh, what is the problem? Value as int. Let's run that once more. Let's restart our application and see if everything works. That's weird. We were not expecting that. While calling unchanged. Probably we are defining that as a string and that cannot be converted to integer. Let me see. We need to convert a string to an integer value. Oh, I probably am doing the typecast the wrong way. Let's do this. Okay, we need to use this try parse to try to get the number from the string and parse that as an integer. Otherwise, if we get a new value, we just pass 0. Let's try once more. But now we are passing this as a second number. Two. So what is the problem? Let's check our Cubit. Second number, results, second number, first number. Let's see in our page if we are doing anything. Oh, first number, twice. Let's convert to second number. And brilliant. Let's hot reload. Aha. 1 plus 1, 2, 1 plus 12, 13, 1 plus 14, 15, perfect. That is our page with Cubit. But a quick note about that. The watch function is very useful when we have a page, a stateless widget, where all the content or almost the entire content relies on state management, which means if we have for example, if we have like a home screen where most of the content is static, doesn't rely on a Cubit, if we change that, everything in the level of this watch function will be recalculated, will render again, and for performing purposes, that's not a good idea. So what we can do, we can wrap. Let's first replace watch by read, which is a function that only retrieves the Cubit, but it doesn't, in fact, listen to the Cubit. So we only retrieve the reference because we need to trigger UI events, right, to the view model. So let's keep that as a read, and here we are going to wrap this text in a block builder. And we are going to pass 2 values here. There are 2 generic types associated with this widget, which are the sun calculator, view model, and the sun calculator state. What is the problem? We need a builder, not a child. So you're gonna pass it contents, which is the object that resumes all the information about our current position in the tree, and state. Okay, these are the two parameters that we need. Let's remove view model and pass state. Move view model from here. Move view model. And those are the three values that we need. Let's save and hot reload. Same result. So, this was our quick introduction to Cubit in Flutter. All the features that currently exist in stateful widgets fit the Cubit in Flutter block. And with that, we don't even need to trigger a new UI rendering when some piece of the state changes, because the static content can still be the same without the need to a second rendering. I hope you enjoyed this content and you stay tuned on CodandoTV content. Bye!